Hi guys, we will see another problem on velocities in mechanisms. The angular velocity of crank OA is 600 rpm. Determine the linear velocity of the slider D and the angular velocity of the link BD. When the crank is inclined at an angle of 75 degree to the vertical, the dimensions of various links are OA equal to 28 mm, AB equal to 44 mm, BC equal to 49 mm and BD equal to 46 mm. The center distance between the center of rotation O and C is 65 mm. The path of travel of the slider is 11 mm below the fixed point C. The slider moves along a horizontal path and OC is vertical. Let us start to draw the space diagram first. In this numerical, number of links are given equal to 6. So we write down all the links in sequence form. First link is AO, second BA, CB, DB, DO, AOC. Okay. So AO is the crank which is 0.028 meter long. BA is the crank which is 0.044 meter long. CB is another link 0.049 meter long. DB is 0.046 meter long. OC is 0.065 meter long. For drawing a space diagram, we have to use the proper scale. First, we locate the point O and C. These are the fixed point. The distance between OC is given to you 0.065 meter long. Now take an angle of 75 degree. Draw the crank AO first with its anti-clockwise motion. With its angular anti-clockwise motion. Now draw a link AB and BC with their proper dimensions. Then draw a link DB. Okay, and let here D is the slider, shows the slider path also properly. For velocity diagram, we have to write down the all linear velocities that is shown in the third column. VAO, VBA, VCA, VDB, VDO and fix. So from this linear velocity we can write down the vectors in fourth column which is shown in the table. OA, VAO means velocity of point A with respect to O, that is written as OA, not AO. Another velocity VBA, that is written as AB, not BA. VCB, BC, VDB, DB, VDO, OD in fixed point. Now let us start the velocity polygon. For velocity polygon, we have to locate the fixed point first, O and C at one point. Then draw first vector OA. O is starting point, A is end point. For velocity diagram, again we have to use the scale. The velocity of vector OA is known to you, that is 1.76 meter per second, that is written in the table. So hence we can obtain the position of point A. After getting point A, draw the vector AB which is perpendicular to link BD in the space diagram. Link AB in the space diagram. Still we don't get the point B. Use another vector BC, CB, which must be drawn perpendicular to link BC. BC and AB vectors meet at point B. Now from point B we can obtain the position of point D by drawing a vector perpendicular to link DB in the space diagram. Still we don't get the point D. Now draw a vector parallel to the path of slider from point O up to D. So we will get the position of point D also. So in this way we can complete the velocity diagram. For understanding, we can arrange this velocity diagram. This is the complete velocity diagram. So this velocity diagram can be well understood by arranging it on the speed diagram. So this diagram shows the arrangement of velocity diagram on speed diagram. Now you can observe that each and every vector is perpendicular to the link except slider. Now vector OA is perpendicular to link AO. Similarly, vector AB is perpendicular to link AB. Then vector BC is perpendicular to link BC. Then vector BD is perpendicular to link DB. And vector OD is parallel to the path of slider. Now, in this way we can understand that how to draw the velocity diagrams. In table, we have to determine the velocities of some links. It is asked in the numerical that we have to determine the velocity of link DB as well as velocity of slider. So in the table, it is calculated the velocity of link DB as well as link velocity of slider D. Similarly, we can calculate the angular velocities of link DB also, which is shown in the table, that is 36.96 radian per second clockwise. In this way, we can determine the velocities, linear velocities as well as angular velocities in the given mechanism. Thank you.